Chapter 4, Strong Acid, Strong Base, Class Life Sciences. Part 2, Autoprotolysis of water or auto-ionization of water. At the end of this session, students should be able to define the autoprotolysis of water, define the ion product of water. Autoprotolysis of water. Definition. The hydrogen atom H11 is formed of one proton in its nucleus and one electron in the electron cloud. It has no neutron in the nucleus. When the hydrogen atom loses one electron, it is transformed into hydrogen ion H+, plus one electron. The hydrogen ion is just a proton. Then we call the hydrogen ion a proton. Autoprotolysis of water is the limited, that means incomplete, auto-ionization of water to produce H+ ion, which is the proton, and hydroxide ion HO- according to the following equation. H2O ionized into H+ and HO-. The ionization of water is self-ionization, then it's called auto. Protolysis decomposition, because OH, the bond between H and OH is broken down to give H+ and HO-, but this reaction is reversible, incomplete. Then this is a lysis decomposition, and proto, because it gives a proton H+. This is the definition of autoprotolysis of water. The water molecule ionizes to give hydrogen ion and hydroxide ion. Hydrogen ion, it does not remain as H+ in water. It associates with water molecule to form the hydronium ion H2O+, according to a complete reaction of equation. H+ plus H2O give H2O+. The hydrogen ion associates with water molecule to give the hydronium ion H3O+. The overall reaction of autoprotolysis of water is H2O gives H+ plus HO-, and H+ plus H2O give H3O+. The sum of these two reactions we simplify by H+ after the arrow and before the arrow. It remains 2H2O give H3O+ plus HO-. This is the equation of the autoprotolysis of water. H2O plus H2O, two water molecule. One hydrogen atom is transformed from one molecule of water to other as H+. Then it gives, the first water is transformed into H2O+, and the second water is transformed into HO- ion. This animation shows the auto-ionization of water. It gives HO- and HO+, but the reaction is reversible. HO- plus HO+ give HO again. Then the reaction is reversible. And the hydrogen ion is not localized to one water. It is delocalized. That means it moves around all water molecules. Degree of auto-ionization of water. Is the auto-ionization of water complete or incomplete, and to which amount the water ionizes? At 25 degree, the pH of pure water is 7 because pure water is neutral. Since pure water is neutral, then the concentration of H2O plus equal concentration of HO minus in case of a neutral solution. And the concentration of HO plus equal 10 negative pH. pH equals 7, then the concentration of HO plus and of HO minus in pure water equal to 10 negative 7. The density of pure water is 1 kilogram per liter. That means the mass of 1 liter of water equal to 1 kilogram, that means 1000 gram. Number of mole of water in 1 liter equal mass over molar mass equal 1000 over 18, that means 55.55 mole. This is the number of mole of water in 1 liter. That means the concentration of water is 55.55 mole per liter. 2H2O give HO plus HO minus. This is the general equation of auto-ionization of water. At T equals 0, the concentration or the number of mole of water equal 55.55 mole of HO plus and HO minus before the ionization 0. At equilibrium, minus X variation for water minus plus 1 over 2X plus half X for H2O plus and HO minus. Stoichiometry 1 over stoichiometry 2, 1 over 2. For product plus and for reactant minus. At equilibrium, it remains 55.55 minus X for water. Its form 0 plus half X equal half X and 0 plus half X equal half X for HO minus. But half X is the number of mole or the concentration of water which equal to 10 negative 7. That means X equal to 10 negative 7. 55.55 minus 2 10 negative 7 is approximately 55.55 because 2 10 negative 7 is neglected with respect to 55.55. Therefore, the number of mole and the concentration of water remains equal to 55.55. The degree of ionization of water equal number of mole of H2O ionized over initial number of mole of water equal 210 negative 7, which is X, over 55.55 equals 3.610 negative 7, which is close to 0. That means the auto-ionization of water is neglected and water remains water. Now, ion product constant of water represented by Kw. The auto-ionization of water is characterized by an unchanged composition at equilibrium at a given temperature. The equilibrium constant relative to concentrations of the equilibrium 2H2O give H2O plus HO minus. This is the equilibrium of the auto-ionization of water. The constant of equilibrium Kc equal concentration of product over concentration of reactant power 2. Since Kc is constant and concentration of water constant, then Kc times concentration of H2O power 2 equal concentration of HO plus times concentration of HO minus. Constant times constant equal constant. Then concentration of water is constant as we have seen in the last part, and therefore Kc, which is constant, times concentration of H2O power 2, which is constant. Constant times constant equal constant. This constant is the ion product of water, represented by Kw. Then concentration of HO plus times concentration of HO minus equal constant. This constant is represented by Kw and called ion product of water. Therefore, Kw equal concentration of H2O plus ions times concentration of HO minus ions. At 25 degree, concentration HO minus equal concentration HO plus equal 10 negative 7. Then Kw equal 10 negative 7 times 10 negative 7 equal 10 negative 14. Kw is a constant without unit. Kw depends only on temperature. It increases when the temperature increases and vice versa. Application 3. The concentration of hydroxide ions in a solution is HO minus equal 5 10 negative 4 mole per liter. A. Determine the concentration of H3O plus ions in this solution. B. Deduce the pH of this solution. Solution of application 3. Part A. We are given the concentration of HO minus. We have the relation concentration of H3O plus times concentration of HO minus equal Kw, which equal to 10 negative 14 at 25 degrees. Our study is restricted to 25 degrees. Then we can say HO plus times HO minus equal 10 negative 14. Then concentration of H3O plus equal 10 negative 14 over concentration of HO minus equal 10 negative 14 over 5 10 negative 4 equal to 10 negative 11 mole per liter. B. Deduce the pH. pH equal negative log concentration H3O plus equal negative log 2 10 negative 11 equal 10.7. This is the end of part 2, auto-ionization of water.